Hello, good morning. This is third BTech EC students. Good morning to all of you. This is Industrial Electronics by Professor Iswar Reddy. We are discussing unit 5 on ultrasonics. Yesterday, or day before yesterday, we discussed about how to generate ultrasonic waves and also applications of ultrasonic waves. Now, this is the third lecture on ultrasonic waves. We will continue. Yesterday, we had discussed about 7 applications of ultrasonic waves. Now is the 8th application, ultrasonic waves for removal of microparticles from industry fumes. Fine particles less than 2.5 microns present in industrial fumes, industrial gases, are very dangerous because they are very small microns. They penetrate deeply into lungs, and they will go and will be attached to the respiratory tissues very easily, and they are highly toxic. Okay, they create a lot of problems, breathing problems. Okay, so removing these micro particles or fine particles is very important. So if you are sending ultrasonic waves, they can remove these tiny particles and ultimately solve the problem of air pollution. We get almost pure air. If large particles are there, they are not much dangerous. Okay, they remove minute particles. So another important application of ultrasonic waves is ultrasonic wave soldering. High intensity ultrasonic waves can be used for soldering stainless steel, aluminum, some other metals and alloys. The metal surface get easily tinned and soldered. Okay. So ultrasonic wave soldering is also used. There we use high intensity, high power ultrasonic waves. Use high intensity soldering for stainless steel, aluminum, some other metals and alloys. The metal surface get easily tinned and soldered. Number 10, ultrasonic wave cold welding. So ultrasonic waves are also used for welding purpose. So you can see the diagram, ultrasonic wave cold welding. Okay. So here ultrasonic waves are produced by UV transducer. Okay. The transducer produces ultrasonic waves that is concentrated by a tube-like thing uh, and supplied to the tool. So the concentrated ultrasonic waves are supplied to the tool, and the tool is held under constant pressure, so that due to ultrasonic waves, alternating stresses are produced by tool on the plates, causing them to rub over each other, producing heat. The temperature rises sufficient for welding purpose. So thus how ultrasonic welding is done. Okay, the plastic objects can be welded together. Okay, thin foils, aluminum foils, like that. Aluminum foils can be welded using ultrasonic wave cold welding. So here welding is not that much hot, so it is not that much dangerous. Okay, so at the same time it is used in number of applications, particularly for welding plastic objects or welding aluminum foils, thin aluminum foils. Okay, can be welded together and can be packed, particularly in packing this ultrasonic cold welding is used, where they can be packed very effectively, okay, using this ultrasonic cold welding. Next, 11th application is separation of mixtures by ultrasonic waves. When different components of liquid or gas having different molecular weights are irradiated by ultrasonic wave vibrations, resulting pressure difference causing molecules to move in the direction of wave propagation. Heavier components lag behind the lighter components, lighter ones. That's how it separates heavier and lighter. Similarly, in liquid, greater density assemble at antinodes of pressure, while lighter density they collect at the nodes. Okay, so this method is used in paper industry where it can separate mixers. Okay, that is heavyweight particles and lightweight particles, both in the liquid and the gas. Okay, this is also very effective in the paper industry. Okay, different different particles having different molecular weights are irradiated by ultrasonic vibrations because it's only sound vibrations it produces. So resulting in what you call the heavier particles, they remain there and lighter particles are scattered far off so that we can separate heavier and lighter particles, heavier components and lighter particles. Similarly, in the liquid, we can separate high density and low density, okay, greater density and lighter density particles. Okay, that is what is the separation of mixtures by ultrasonic waves. Then degassing of liquid by ultrasonic waves. When ultrasonic waves of low energy are sent through liquids, gas bubbles are formed. When ultrasonic waves of low energy are sent through liquids, gas bubbles are. These bubbles are produced by union of microscopic bubbles already present in the liquid. So bubbles are formed, of course. So already minute bubbles are there. These bubbles are combined and these bubbles will blow off and the gas will come out of from the liquid. Okay. So bubbles are formed due to the following two reasons. One is expansion of liquid due to ultrasonic wave leads to negative pressure in the liquid and results emergence of gas. Okay. Dissolved in it and hence formation of bubbles. Okay. Number two, phenomena of cavities. Degassing of liquid depends on frequency of ultrasonic wave. Degassing of oil can be obtained at low frequency. So based on the frequency of the ultrasonic wave, we can remove the gas from the liquid or from the oil. Okay, different methods are used to remove the gas from different liquids, and gas can be removed liquid like oils also. That is what you call degassing of liquids by ultrasonic waves. Okay, very important phenomena which is used in the industry. Okay, we can remove gas very effectively using ultrasonic waves. Okay, next, ultrasonic number 13 is ultrasonic drying. Ultrasonic vibration, there after all sound vibrations are used in drying process in some industries. Ultrasonic wave drying process is faster than other methods. Ultrasonic vibrations, they are used for drying purpose in industry because it is very fast and also effective. Example, drying of glass fibers. In chemical industries, drying of charcoal, alumina, silicon, gel, etc. In chemical industries, drying of charcoal, alumina, silicon, gel, etc. Ultrasonic drying is simpler and faster than other methods. Ultrasonic drying is used instead of thermal drying method. Okay. So ultrasonic drying, one of the most effective method, because ultrasonic vibrations are nothing but sound vibrations which are used for drying some of the particles like glass fibers, okay, charcoal, aluminum, silicon, gel, etc. can be dried very easily and very fastly. Compared to thermal drying, this method is preferred. Okay, ultrasonic drying is preferred compared to thermal drying. Okay. Then number 14, physiochemical effects. Ultrasonics are useful in electrochemical industries. Ultrasonic irradiation is used in the manufacture of pharmaceutical industry. Okay. Number 15, chemical effects. Ultrasonic radiations change certain chemical reactions by changing frequency and intensity of ultrasonic radiation. We can control the rate of chemical reaction and direction of chemical reaction. Okay? Ultrasonic radiation changes certain chemical reactions. By changing frequency and intensity of ultrasonic waves, we can control the rate of chemical reaction and also direction of chemical reaction. Thus, we can speed up the process of polymerization and depolymerization and depolymerization. Okay? These are nothing but chemical effects of ultrasonics. Then thermal effects. Ultrasonic radiation in liquid results rise in temperature of liquid. So for example, if your ultrasonic waves are radiated into liquid, liquid temperature is raised. For example, if you take 2 cc of water radiated by ultrasonic waves for 10 seconds, will raise temperature by 2 degrees centigrade. 2 cc of water radiated by ultrasonics for 10 seconds will raise temperature by 2 degrees centigrade. Of course, if you use instead of water glycerin, the temperature rises by 10 degrees centigrade. Then stearic acid, the temperature rises by 36 degrees centigrade. If you use wax, temperature is raised by 44 degrees centigrade. Okay, this heating effect of ultrasonic waves may also be used in medicine, in diathermy. Okay, there is ultrasonic diathermy, where the heat is used for treating purpose. Okay, treating of certain pains, diathermy. Then, so the thermal effects of ultrasonics is very important subject, where liquid temperature can be increased or water temperature can be increased, and also used in medicine for diathermy by producing heating effects. So thermal effects are nothing but heating effects of ultrasonics. Then 17, biological effects of ultrasonic waves. Ultrasonic radiation in liquids produce effects like cavitation, degassing, heat production, oxidation, and dispersion. Ultrasonic radiation in liquids produces effects like cavitation, degassing, heat production, oxidation, and dispersion. Strong ultrasonic radiation causes destruction of bacteria, okay, in the liquid, and also microorganisms. So if you strong, very high intensity ultrasonic radiation is focused into liquid or water, whatever it may be, the bacteria will be destructed and also microorganisms. Ultrasonic radiation causes yeast cells to lose the power of reproduction, and also protozoa gets destroyed. Okay? So, biological effects of ultrasonic waves. Ultrasonic radiation in liquids particularly produces what we call cavitation, degassing, remove gas, and heat production, oxidation, and dispersion. So, number of applications. It produces what we call cavitation, degassing, removing gas, heat production. It produces heat, and also oxidation and dispersion. So, strong ultrasonic radiation causes destruction of bacteria also, and also many microorganisms. And also ultrasonic radiation causes yeast cells to lose the power of reproduction, and also protozoa gets destroyed. Okay, these are of course biological effects of some of the biological uh, microorganisms can be killed by the ultrasonic waves. Okay, so this is also very important application of ultrasonic waves. Then we have very important application of ultrasonic waves. Ultrasonic stroboscope. When light is diffracted by a stationary ultrasonic wave, the intensity of all light spectra becomes intermediate at twice the frequency. Thus, we get modulation of light by a frequency of 2fs, where fs is of course ultrasonic frequency. A stationary ultrasonic wave thus is used to produce modulation of light for stroboscopic illumination. This method gives much better output and illumination. Okay, with a simple optical arrangement. Okay, than conventional method. The degree of modulation so produced may be measured by a photodiode. It is possible to produce almost 100% modulation of the different lights. Okay, diffracted light. It is possible to produce almost 100% modulation using ultrasonic waves of diffracted light. Okay, so ultrasonic stroboscope has special value for very high frequencies. Ultrasonic stroboscope, yes, however, always used for definite frequencies only. Hence, continuous change of ultrasonic stroboscope illumination is not possible. Okay, so these ultrasonics are used in the stroboscope for getting better illumination. Okay, compared to conventional method. That is one important application of ultrasonics. Ultrasonic waves as means of communication. Okay, ultrasonic waves may be used for sound signaling. Ultrasound waves, particularly high frequency, may be used as a beam. They are concentrated. You can send as a beam and sent in the desired direction. Okay, ultrasonic waves may be produced and they are sent to a conical like tube where the beam is very narrow and concentrated. Okay, and we can send this beam to the desired direction. We can produce narrow beams with low power. Okay, power is low but beam is very narrow, so that intensity is more and can radiate with a great intensity. Okay, of ultrasonic waves. Okay, power source is of course low power source, but still we can concentrate it and increase its intensity. Okay, these submarine ultrasonic wave transducers have been developed for detecting iceberg, submarines, etc. in the ocean. Okay, submarine ultrasonic wave transducers have been developed for detecting iceberg in the ocean and submarines, etc. Okay, otherwise the ship may go and collide with the iceberg or already immersed submarine. Ultrasonic wave transducer can generate powerful ultrasonic waves of frequency 40 kilohertz. So high intensity, high frequency ultrasonic waves are generated, okay, which can detect submarines and also icebergs, okay, for smooth travel of the ship. Okay, so for ship to move safely, we must know is there any icebergs are there beforehand, maybe 15 or 20 kilometers before. We must know what are the any submerged these things are there in the ocean, like icebergs and submarines. Already some submarines may be there, which can be detected using ultrasonic sound signaling. So that is more effective. Okay, and which gives a lot of communication also to the for if already ship is there, we get communication. Already submarine is there, we get communication. Okay. These submarine ultrasonic wave transmitters may be used for, number one, for signaling from ship to ship, especially submerged submarines. For signaling from ship to ship, especially for submerged submarines. They use specially designed submarine ultrasonic wave transducers for horizontal propagation. The signal is sent for horizontally. The typical range is about 15 kilometers and accuracy of direction is 1 degree. Okay? Signaling may be done by Morse code or by telephony. The quartz vibration being modulated by speech frequencies. That is what is sound signaling. Okay? The ultrasonic wave produces ultrasonic vibrations which are modulated by speech frequencies. So they are sent to the sound signal from ship to ship. Okay? And particularly even submerged submarines also. We can have communication, underwater communication. Okay? That is what we call sound signaling. Number two, determination of position of ship, submerged submarine, etc. Here, so-called echo principle is used. The working is like pulse radar. So pulse radar, it sends transmitting pulse and receives an echo. So we can find out the distance of the target. Similarly here, pulses of ultrasonic wave signals are sent out from the transmitter at short intervals, maybe 1 millisecond. The return echo is received in the ultrasonic receiver, and time interval between transmitted and received signals T1, T2, T minus T1 is noted. Knowing the velocity of sound waves in water, the distance may be calculated. You can note down the diagram. It consists of ship, below that ultrasonic wave transmitter, ultrasonic wave receiver. The transmitter sends 1 millisecond pulse, high intensity pulse. So it is reflected, it goes underwater and reflected from the ship and comes as echo. And the receiver will receive this echo. Okay? The timing is noted. Timing of sending of pulse, timing of receiving of the pulse. T1 is sending of pulse, T2 is timing of receiving of pulse. If the velocity of the ultrasonic wave in the water is v, then the distance, the wave travels twice the distance. 2r is equal to v into T2 minus T1. So r is nothing but v by 2 T2 minus T1, where v is the velocity of the ultrasonic wave in the water. T2 minus T1 is the time lag, time difference between sending pulse and receiving pulse. Okay? So the distance from ship to ship can be measured, r is equal to v by 2 T2 minus T1. Then third is determination of depth of sea. One of the very important application of ultrasonic waves, using again echo principle. Here also echo principle is used. Same diagram. Only thing is it goes now vertical instead of horizontal signaling. Here the echo principle is used. It has advantage that it can take soundings in shallow water. Okay, it goes now into sea, ocean, and the accuracy is also very good. So we send a vertical signal, okay, from the ship, and you can find out the depth of the sea by getting a reflected echo from the bottom of the ocean. Okay, a ultrasonic wave piezoelectric transducer produces 40 kilohertz pulse, 1 millisecond pulses, and ultrasonic, and it is received. Okay, time between transmitted and received pulses is noted, just like the above one. The depth of the sea now can be determined. D is equal to V by 2 T2 minus T1. Okay. The ultrasonic wave transducer used here is piezoelectric crystal followed by an amplifier and time measuring device. Okay, it has to find out what is the transmitting time of the pulse, what is the receiving time of the received echo. Okay, so that is, it must be accurately measured timing. Then velocity of the ultrasonic wave in the sea, already we know it. Then depth of sea, d is equal to v by 2 t2 minus t1, just like the uh, determination of position of second case. The depth of the sea also can be measured using ultrasonic waves. Okay, so ultrasonic wave communication is very effective, particularly in the ships and in the submarines. We can find out the distance of the next ship, distance of the submarine, distance of any iceberg in the water, and the depth of the sea also, how much depth it is there. So that the safe travel of the ship can be achieved using these methods. I think this these are the some of the applications of ultrasonic waves. We have plenty of applications. We have discussed about 19 or 20 applications, okay, both in industry and also in communication, in the ship, in the water, okay, underground water, sound signaling purpose, okay. So the ultrasonic waves, study of ultrasonic waves, and is very important because it has enormous number of applications, okay. So this, we stop the video here and we will continue unit 5 tomorrow. Okay, thank you.